Hello learners, welcome to today's virtual class. My name is Mr. Wawero Paul. I'm a teacher of mathematics and physics. Today we're going to look at mathematics form 3. Our topic of discussion is going to be further logarithms. Now, I may need you to have the following two topics in form 2 as a prerequisite knowledge. I'm talking about logarithms and I'm also talking about indices. Welcome. Specific objectives. By the end of the lesson, the learner should be able to A. Derive logarithmic relation from index form and vice versa. B. State the laws of logarithms. C. Use the laws of logarithms to simplify logarithmic expressions and solve logarithmic equations. And D. Apply the laws of logarithms for further computations. Now, in form 2 we learned the topic indices, and we say that indices refer to powers, exponents, in singular form index. When, for example, we write 2 cubed equals 8. What this means is that we have three numbers. We have 2, 3, and 8. 2 is referred to as the base. All right. 3 is referred to as the index, plural indices. It is also referred to as the power. We can also call it the exponent. And now we shall be calling it logarithm. So 3 can also be called the logarithm. And 8 is obviously the number. So this way of expressing numbers such that when you say 2 cubed equals 8 is what is called the Untitled notation. From the word index. Now moving on to what we are calling the logarithmic notation. There is a way we can express 2 to the power 3 equals 8 in form of logarithm. And this means when you see 2 to the power 3 equals 8, we can start by writing log, then to the base. And in this case, the base is 2. So the log to base 2 of what? The number. That number is 8. And that log is what? That log is 3. All right. I want to repeat. We are saying we are considering the three numbers 2, 3, and 8, and we have said that 2 is a base, so we can say the log to base 2. The log to base 2 of which number? Number 8 of 8 is 3. And this way of expressing numbers is what we are calling the logarithmic notation. Let's take one more example. When you write 5 squared equals 25, what do we mean? In this case, just like before, 5 represents the base, 2 represents, we now know, represents the logarithm, and 25 represents the number. So if you want to write this in logarithmic notation, we shall write log, then we start with the base, and the base in this case is 5, followed by the number. The number is 25, and that will give us 2. So in short, the log to base 5 of 25 is 2. Just like I've mentioned before, log to base 5 of 25 equals 2 is what is referred to as the logarithmic notation. So I want you to try the following. Express the following in logarithmic form. Now, you may have written the following. For the first one, log to base 4 of 16 equals 2. That's the answer, the logarithmic notation of that. Number 2, you may have written log to base 3 of 81 equals 4. And number 3, you could have written log to base 10 of 1000 equals 3. Let's start with the product law. When we are multiplying, for example, when you write log to base a of m times n, whenever we are multiplying numbers involving logarithms, when we open the brackets, when we expand, we add. So in this case, we shall have log to base a of m. Because we are multiplying on the left hand side, on the right hand side, when we open the brackets, we shall add, and we shall have plus log to base a of n. They are both under one base. Conversely, when we are dividing, log to base a of m over n, where we are dividing on the log side, when you open the brackets, we shall subtract. So we shall have log to base a of m subtract log to base a of n, and the vice versa. If you are on the right hand side, you can always go back to the left hand side by combining them and dividing or multiplying. Let's have a few examples. Now, we have said this is the product rule, and this is the quotient rule. Let's have an example. For example, when you say log to base 10 of 3 times 5, log to base 10 of 3 times 5, what we actually mean is that this is log to base 10 of 3 plus log to base 10 of 5. Now, let's use our calculators to prove whether when we multiply 3 times 5, we shall have 15. So let's use our calculators to see whether log to base 10 of 15 is the same as log to base 10 of 3 plus log to base 10 of 5. So let's start with the log to base 10 of 15. Remember, just like you shall see later, if the base is not given, it should automatically be base 10. So log to base 10 of 15 is 1.1761. 1.1761. All right, let's keep that in mind. Now let's get the log to base 10 of 3 plus log to base 10 of 5. Remember, the answer we had found for log to base 10 of 15 was 1.1761. And now again, we can clearly see that log to base 10 of 3 plus log to base 10 of 5 is 1.1761. So we have proven that log to base a of m times n is the same as log to base a of m plus log to base a of n. Now, let me give one more example. Log to base 10 into bracket 30 divided by 5. All right, what is that going to be? We have seen that's going to be log to base 10 of 30. Now instead of divide, we shall subtract, because we are dealing with division. So we're going to subtract log to base 10 of 5. On the left hand side, it's the same as writing log to base 10. 30 divided by 5 is 6. Let's see, is log to base 10 of 6 the same as log to base 10 of 30 minus log to base 10 of 5 from our calculators? So let's get log to base 10 of 30 over 5, which is 6, and the answer is 0.7782. all right, then let's see whether that is the same as log to base 10 of 30, log to base 10 of 30 minus log to base 10 of 5. Remember, our answer was 0.7782, and again our answer is still 0.7782. In our proof, we shall consider the equations that deal with the indices, and we know them. 8 power m times 8 power n equals 8 power m plus n to 8 power m divided by 8 power n equals 8 power m minus n, and 3 8 power m raised to power n equals 8 power m n. Now let x to represent 8 power m and y to represent 8 power n. All right, now let's express these two in logarithmic notation. So for the first one, we shall have log to base a of x equals m, and for the second one we shall have log to base a of y equals n. Therefore 8 power m times 8 power n equals x y, and we can combine what you have on the left hand side we shall have a to power m plus n, and that is going to be equal to xy. Now this is in indical form. Let's express it in logarithmic form. So this is the same as writing log to base a of xy equals m plus n. On the left hand side we have log to base a of xy. Let's combine them like that, in which case we shall have log to base a of x. Because we are multiplying, we shall add log to base a of y, and that is equal to m plus n. So in short, we can clearly see, remember the relation we wanted to prove is that log to base a of xy equals log to base a of x plus log to base a of y. And we have already seen that m is log to base a of x and n is log to base a of y, hence the proof. Now to prove the quotient rule, we are considering the equation a to power m divided by a to power n, and we know that this is basically the same as a to power m minus n. So let a to power m be represented by x. So a to power m represents x and y represents a to power n. Now instead of having a to power m divided by a to power n, we shall have x divided by y being equal to a to power m minus n. Now from these two we can express them in logarithmic notation. So for the first one we shall end up with log to base a of x equals m, and for the second we shall have log to base a of y equals n. Therefore, that being the case, a to power m divided by a to power n must be equal to x divided by y. Instead of writing the division, let's put them over. So a to power m over a to power n equals x over y, like that. On the left hand side we can use the laws of indices to combine it. So we shall have a to power m divided by, m, you subtract n because we are dividing, and that should be equal to x over y. And at this juncture we can express this in logarithmic form. So let's express this in logarithmic form. So we shall have log to base a of x over y equals m minus n. All right, and if you remember this very well, we can actually open the brackets. Opening the brackets, we shall have log to base a of x. Because we are dividing, we shall now subtract and have log to base a of y being equal to m minus n. If you remember very well, we have just seen that m represents log to base a of x and n represents log to base a of y. So we have proven that indeed the left hand side is the same as the right hand side. When you write log to base b of x raised to power c, what this means, we have a power. This is the same as c log to base b of x. If I give another example, log to base a of y to power 1 over n. This is the same as 1 over n log to base a of y. For example, when you write log to base 3 of the fifth root of 27, what this means, this is the same as log to base 3 of 27 raised to power 1 over 5. Cube root means, fifth root means to power 1 over 5. And then this would be the same as 1 over 5 log to base 3 of 27. All right, and then we can simplify this further and write, we know that 27 is the same as 3 cubed, so this is the same as 1 over 5 log to base 3 of 3 cubed. Again, 3 will move behind, so it will be 1 over 5 times 3 log to base 3 of 3. And what we need to note at this juncture, whenever you see the log of a number to the same base, what that means is that the answer is simply 1. So we shall just end up with 3 over 5. So in short, another law that we need to underscore is that the log to base a of a is 1. We can have the laws of logarithms as follows. Number 1, the log to base a of a times b equals the log to base a of a plus log to base a of b. 2, the log to base a of a over b is the same as log to base a of a subtract log to base a of b. Number 3, we have seen that the log to base a of a is 1. Another one that you have seen is that log to base a of b to power n, we have seen that that is the same as n log to base a of b. So we shall be using this and many others to solve problems involving logarithms. And now for your assignment, I would want you to try the following. Question 1. Express the following in logarithmic notation. So number 1, you have to express in logarithmic notation. 7 squared equals 49. B, 10 raised power minus 2 equals 0.01. C, 125 equals 1/5 raised power minus 3. D, 1 equals a to power 0. And E, we are having 9 to power minus 3/2 equals 1/27. That's question number 1. You're supposed to express in logarithmic form. And question number 2, express in index notation. Index. A, the log to base 5, 625 equals 4. B, log C, equals 2. Question 3, simplify the following. A, log 3 plus log 4. B, log 6 minus log 2. C, log 2 plus log 6 minus log of 4. D, log to base 3 of 27 plus log to base 3 of 10. And one more question. You're supposed to simplify the following. The log x plus 1 minus log x squared minus 1. You may want to try that out. In our next lesson, I'll be solving a few of these and many others, and then we shall look at logarithmic equations and expressions. Well, that marks the end of our lesson today, and today we were looking at further logarithms. We have been able to look at the rules that pertain to solving logarithmic equations, and I hope to see you next time. I hope you've understood. I've been your teacher, Mr. Wero Paul. See you next time. Stay safe.